So you have to, before getting into today's class, you have to know about the difference between DTFT and DFT. Okay, so DTFT we have already dealt in the previous class. Okay, so we have dealt in the previous class. So you have to know about the difference between these things. That is, in general, the DTFT is nothing but you will be processing your Fourier. That is, if your x of n is there, means it is a signal. Okay, if x of n is a signal, means for this you will be taking a Fourier transform. Okay, and in DFT also you will be doing the same thing. For your x of n, you will be taking the Fourier transform. Okay, but over here both the signals are discrete. Okay, so it is a discrete signal. So that when you are expressing in x of n, okay, it is a discrete signal. It is also a discrete signal. But the difference is here is that in your DFT, you will be taking with respect to your time period. Okay, so you will be taking with respect to your time. But over here, you won't be considering your time is not considered. Okay, time is not considered. Okay, so that's what they're saying. Uh, so in general, your periodic signal can be expressed expressed in periodic signal can be expressed as a or in a Fourier series. Okay, this you already know. So if this DFT is with respect to your time plane, means okay, similar to your analog and digital concept only. That is, your DFT you can take it in your analog plane, and that is for processing your analog signal, you will be going with respect to your DTFT. The same thing if you are processing with respect to your digital signal, means you will be going to your DFT. Okay, so in general, so you just take it down. The discrete time or DTFT, that discrete time Fourier transform, DTFT, DTFT. Okay, can make it as x of omega. Okay, is a function is or of a discrete sequence The discrete sequence is what I said you are x of n. Okay, this in bracket you put x of n. It's a periodic signal, the periodic continuous function. Okay, you have to make it with reference to the periodic continuous. Okay, you just underline the continuous. Okay, continuous function of omega with period 2 pi. Okay, here what they're saying is that your DTFT is nothing but your continuous signal, like that you can have it. Okay, but in general, both DTFT and DFT are related, but it varies only with respect to your time. Okay, so in a DTFT there will be your time sequence, but in your DFT the time sequence will be absent. Okay, so period 2 pi. Okay, so it is a continuous signal, so this signal cannot be digital. So the signal process signal process from DTFT is continuous. Is continuous. So it's not suitable for digital system. Not suitable for digital system. Okay. So for this, what you have to do, you have to go to DFT. Okay. For this purpose, you have to go to DFT. So what this DFT does? Okay. So now we have to overcome the difficulties faced in your DTFT. So what your DFT does? So your DFT is nothing but what it does means the DFT converts continuous function, that is omega, continuous function. So your continuous function is nothing but omega, which is of period 2 pi. Okay, continuous function of omega with the period 2 pi. Okay, so what it does is it converts your omega function in terms of your discrete. The continuous function with the period 2 pi to a discrete function to a discrete function of omega. Okay. Now is it clear? I think it might be clear for you. So this is the main difference between DTFT and DFT. Okay. So in this unit we will be covering entirely covering about DFT and its counterpart IDFT will be covering. Okay. So this DFT is denoted by, so your DTFT was denoted by x of omega. Okay, but over here your DFT will be denoted by x of k. Okay. So technically speaking, now we will be seeing how you will be converting your continuous function of omega to a discrete function of omega. Okay, so that we'll be seeing. So this is another theory part. If you are having some knowledge of this theory part, you can easily get into the problematic. So now I have told you why we are going for DFT and what is the main difference for DFT, DTFT and DFT. Okay. So next is how this DFT is obtained. So DFT is obtained. Generally, your DFT will be obtained from your DTFT only. DFT is obtained by sampling by sampling one period of Fourier transform. Okay, generally from a Fourier transform only will be getting your DTFT. So Fourier transform x of omega of signal x of n at a finite number of points, at a finite number of frequency points. So what they're saying is, in order to get your DFT, okay, in order to get your DFT, sampling has to be done. Okay, Sampling has to be done over your Fourier transform. But how this sampling must be? Okay, how this sampling must be means it must be sampled for finite number of your frequency point. That is, there must be some equal interval between your sampling time period. Okay, so the time period of sampling must be equal. So what they are saying here is the sampling is the sampling is performed sampling is performed usually at n n capital N. Okay, here you have to see n capital N equally spaced points in period 0, that is within your 360 degree period 0 less than equal to omega less than equal to 2 pi, or for a discrete sequence, or generally your omega k, so this is for a continuous and this is for a discrete, omega k will be equal to 2 pi k divided by n, where then k will be 0 less than equal to k less than equal to n minus 1. So this is how you will be getting your DFT. I think you might have got some idea. Okay, so I will be giving an overview. Okay, in general, you already know that there are two types of signal. Okay, one is your continuous. Okay, one is your continuous. Your continuous will be like this, right? So your continuous will be like this. Another one is your discrete. So your discrete will be in this fashion. So these are the two types of signals. Okay, so for these two signals, you might be it is possible to take Fourier transform, right? Why the sense means your Fourier transform you can take it for your periodic signal. For this both the things, I'm just giving an overview so you can easily understand. For Fourier transform, you can take, okay, for your periodic signal. So these two signals are periodic signals. Okay. So next, what you have to know is why you are taking this Fourier transform. Okay, that's the basic thing. So why you are taking this Fourier transform means for mathematically representing, okay, for mathematically representing the signal. Okay, so I'll be dealing very basic concepts. Okay, now I'll be saying so that you can easily understand. So in general, everything around us is in the first class itself I have said everything around us you can represent in terms of the mathematical modeling. Okay, so for example, uh, while we are speaking, sound is liberated, right? Sound is coming from our vocal cord. So this sound will be between some audible range, some hertz, right? I think up to 20,000 hertz it's there, right? So this within this audible decibels, what is there means the sound, how the sound waves will be. I'm just talking in general. Okay, why we are using DTFT, why we are going for DFT, I'm saying. Okay, so the sound signals are represented in which format? How the sound signals will be? You can just type in the chat box how the sound signals will be. How the sound signals will be. You can just type in the chat box. I didn't get any reply. The sound what we are making will be of what kind of signal? Okay, you no need to say it is a continuous or discrete. Okay, but it's continuously, right? But I am asking about the shape. What is the shape of the signal? Whether it will be a square wave or whether it will be a triangular wave. Yeah, it is a sine wave. Okay, it is a sine wave. So in general, most of the uh, vibrations through which the sound is liberated, okay, will be of either sinusoidal or cosine. Okay, either it will be sinusoidal or cosine. For example, if if it is possible for you, you can just browse it in the net. That is, even in the nature, everything the sound will be of either sine or cosine only. For example, if water is falling from a waterfalls means, if you are having any kind of acoustic sensors, okay, or some kind of tools to uh, measure the signals of the sound means, okay, what you can see is that that output of the sound will be sinusoidal or cosinusoidal. Okay, yeah, vibrations. Apart from this, the vibrations are nothing but your sudden spikes in this sinusoidal waves. Okay, so be it clear. I'm just giving a general talk. Why you are studying these DTFT, DFT? Okay, if I'm still moving on, means surely you won't be understanding anything. So I'm just giving an overview. So yeah, we left at the waterfalls. Okay, so at the waterfalls, if you're recording the sound means surely it will be a sinusoidal wave, and or either it will be sinusoidal or cosinusoidal. Similarly, for everything, even if the falling of a raindrop in a leaf, everything it will be of sinusoidal or cosinusoidal. So generally what happens is that you can also model that kind of signals also. Okay, so for such kind of modeling of signals only, we will be studying these kind of transform, Fourier transform. Okay, for example, that signal what you have got will be, you have to extract it through a uh, sound extractor, and you can even give it to your MATLAB software, wherein it is able to process the signal. Okay, so what happened is that why it is necessary to go for such kind of DFT and DTFT means, as Venkatesan said, while coming out with some kind of anomaly in the sense some abnormal situations. For example, uh, your moving of the tectonic plates or your earth bed. Okay, uh, if there is a sudden movement means there might be some causes for your earthquake, right? Similar to that, if the we can go to the same waterfall example, you are recording the sound from the waterfalls, so it is coming to be a sinusoidal wave. You can take it as a sinusoidal wave. You can take it as a sinusoidal wave, which is of 20 hertz. I'm just saying for example, which is of 20 hertz. So waterfall sound. So based upon this, they will be converting this into decibels also. So suddenly, suddenly, if this 20 hertz is increased, if this 20 hertz is increasing to nearly 2000 hertz, okay, so it is suddenly increasing to 2000 hertz, then it is you can say that some kind of abnormal activities has been happened from here to here. At the normal and peaceful situation, you must have around 20 hertz. But some abnormal situation is having 2000 hertz. So abnormal situation in this sense means, for example, you can take Kutralam itself. So in Kutralam, during a normal time period, at the time period of March or April, the what you can say, the flow of your water will be very minimum. Okay, so at that time the water will be very peaceful, and you will be getting around the sound to be 20 hertz. But at the same time, if you're going in a very seasonal time period, means that is in July or August, if you're going, means the flow of water level will be very high. Okay, when the flow of water level is very high, the speed will be very increasing. So it might be lead to some kind of abnormality. What I have said, like what I have given the example. During the April, May, you might be getting 20 hertz. But during the season time at Kutralam, you will be getting around 2000 hertz. Okay. So, in general, what happens is, these kind of representation, why you are studying this kind of DSP or digital signal processing means, these kind of representation will able to say about the state of a system. Okay, for that only you are studying this. It's possible to determine the state of the system using this kind of representation, like DTFT or DFT. Okay, so for that only you will be you have to know about the signals. So that's what we have seen in your first unit. Okay, so that's what we have dealt in your first unit, and in your second unit we will be studying So I think I am audible to you. Okay, yeah. I had a call. Okay, so we can resume it. That's the thing. So in the second unit, we have covered with respect to your time sequence. Okay. So in this, we won't be seeing with respect to your time sequence. Will be entirely converted. Will be in respect to your discrete form. Will be seeing, even though the signal is continuous, you can convert it into discrete. So that's what we have seen in the previous page. Okay, so for this representation only you are studying this kind of DSP. Okay, so mainly where this and the signals are used, it means it will be used in image processing. Okay, image processing they will be using, and apart from that, to study the system, like I said, no, for the example, the waterfalls example, you can take it out. So for these kind of things, you'll be studying like this. Okay. So mainly, it is able to determine the nature and state of the system. Okay. So with this, I think we can stop today's lecture, and I just want you to ask some questions. Okay. So I will stop it.